The question is solve for addition of the zeros. Solve for the additions of the zeros of the quadratic function of y is equal to 3x squared minus 6x minus 4. As we can see, this question is basically about the quadratic function. This question is about quadratic function, especially if you go more specifically, it's about zeros. So, in order to solve for this question, we have three things to know in order to approach this question. The first thing is definition graphs of quadratic function. So, let's think about what is a quadratic function in order to approach this question. So, we are thinking about the quadratic function. And if you think about the quadratic functions, we can think about its basic format. The quadratic function's basic format is y over f of x is equal to ax squared plus bx plus c. This is the basic format of our quadratic function. And if you think about what we call this basic format, we call it as the standard form of our quadratic function. And if you don't know the definition of the standard form, that means it is a most basic format in our quadratic function that we usually notate when it comes to solving this kind of question. And as we can see, the quadratic function, if you convert this into some specific graphs on our coordinate plane, will be a specific parabola that satisfies its own equation. So this is basically about the first one, and the second thing that we need to know in order to approach this question is related to the first one. The second one is effects of each variables or constants in the quadratic function. First thing that we might talk about in the variables or constants in our quadratic function form is what is y and x. So y and x is the most important elements in every single function contains. The first thing is y, or usually we note it as the f of x too. The y or f of x will be the output. It will be an output of our quadratic function in this case. So it will be an output. The output of the quadratic, or in this case, it will just going to be a function. Now if you think about what is the x value in our function, especially in the quadratic function in this case, will be the specific input, the input of the function. The reason why we require an input is because we know that there will be an output of a function which we notate as the y or f of x. In order to make and or generate the output, we always need to require a specific input to make it. And the reason why we say that y and x are the most important elements when it comes to solving the function problem is because we know that we usually notate our y value as the f, and x value will just going to be x. And with that f and x, if we add them together, we're going to get an f of x. And what is an f of x? The f of x will be a function, a short form to show us what the function is. That's why the x and the y are the most important thing or the element when it comes to solving this function problem. And then there are other things exist. And that other things are elements that defines the difference between functions. The first thing that might hit our eyes was what is the a. As we can see, a is a coefficient of the x squared term. So it will be a third thing. What is the a in our quadratic function? As we can see, it is a coefficient, but it is different with just a coefficient. It will be a leading coefficient. It will be a leading coefficient. And if you don't know what the coefficient is, the difference between just a coefficient and the leading coefficient will be defined by the term or the word leading. Because the leading is a short form to refer to a x squared, which is the highest leading power term in the quadratic function. And with that leading term's coefficient, x squared's coefficient, which in this case is going to be a. So that's why we call a as the leading coefficient. So we'll say a value is the leading coefficient, is a coefficient of x squared. This is what the x squared, this is what the leading coefficient will be. And if you don't know what the definition of the coefficient is, the definition of the coefficient means it is a number. So coefficient is the definition of the coefficient in the quadratic function or any other functions will be a number. You know what is number? Numbers beside variables. Now if you don't know what it means by the variables, variables is a terms to describe the terms that never stays at the time, never stays, just changes depends on times. And for the example of our variables will be x and y. The reason is because x input value and the y output values will be different depends on its input value. So the a value is a leading coefficient, but other than the y and x, a value is another most important main element that defines the function. The reason is because we can talk about it more specifically later, but the a value is a leading coefficient that defines our types. The a value defines types, the types of graphs of our quadratic function, as well as the vertex of our quadratic function. And the only reason why we say that a value is important is because we know that the most important thing in the quadratic function is its graphs as well as its vertex. And with that graphs and vertex, it is a thing that actually makes or generates the function. But without graphs and vertex, we can't really see that it is a function in the quadratic function. So that's why the main element that generates the graphs and vertex will be our leading coefficient a. Now the second or the fourth thing that we're going to talk about in the constants in our quadratic function will be our b value. The b value is also a coefficient but different with the a value because it is a coefficient. B is a coefficient, just a coefficient of the x to the first power term. This is a main difference between the a and b. And this is not important when it comes to graphing or in the quadratic function system. And the last one in this case will be what is a c? Well, the c is a y-intercept. C is a y-intercept. And as we can see, we'll talk about what is intercept. And as we can see, the c value is a term that is different with a and b because it is a term that without no variables. And there is a special term to call no variables. We call the no variables terms as the constant. C is a constant. So these are the main 5 things that we need to think about when it comes to thinking about or solving our quadratic function system problems. Now let's think about what does these variables affect to our original function more specifically. Firstly, let's think about what kind of exactly types of graphs and vertex that the a value defines. So the first thing that we're going to talk about is the a value, which we're going to be our leading coefficient. The a value is our leading coefficient, but not a leading coefficient of the linear function, is a leading coefficient of our quadratic function. The a value only exists in our quadratic function. And the cases of our vertex will define by its size, and obviously there will be two cases because it depends on size. There are two cases in our size, whether it becomes a positive value or it becomes negative value. The first case will be when a value, our leading coefficient, is greater than 0. As we can see, whenever the value will the a be, if it is greater than 0, that means it is a positive value. So that means when the a value is positive value, the graph of our quadratic functions will open down upward. So the graph of our quadratic function will opens upward. And if you think about the main example of the quadratic functions graph that opens upward, it will look something like this, that keeps going toward upward and never intersects at one point. But then it will contain one most important point that we need to think about in our quadratic function system, which we call it as, it's located right over here, and we call it as the minimum. We notate it as the minimum or the lowest point on our quadratic function. And this will occur when a value is greater than 0. Now let's think about the second case. The second case will be when a value is less than 0. So we can see whenever the value ab, when it is less than 0, the value will be a negative value, which means it is less than 0. When it is negative, unlike the first one where the graph of the quadratic function went upward, the graph will go downward, which is the opposite part with the first type. And when it goes downward, for example, it will look something like this, that keeps going toward downward, never intersects at one point. But then it will contain another most important thing in our quadratic function, the maximum, or we also notate it as the highest point on our quadratic function, and this will occur when a value is less than 0, when it is negative value. So from here we might think about the definition of our vertex. So from these two things, our definition of the vertex, which is the most important thing in our quadratic function system, will be the addition between the minimum point. It is addition between the minimum point and the maximum point. That means the vertex will be depend. You can also call it as, not right, but we can also call it as the variable, because it changes, depends on the situations, depends on the our leading coefficient a's value, whether it's positive or negative value. So we thought about our vertex, and now it's time for us to think about to see what is the y-intercept in our quadratic function system, and also in other kinds of functions. So the second thing that we're going to talk about, which is the most important thing when it comes to solving this kind of question, will be the types of intercepts. Before we solve for this, we need to think about what is the intercept. Well, the definition of the intercept means there is a specific point on our axis. If it is on the axis, there will be obviously going to be two cases, because there are two axes. There can be either x or the y axis, which means it can be either horizontal or a vertical axis. So the first case of our intercept will be our x-intercepts. Well, the intercept means there's a point on the x value, which means the point is on the x-axis. And we have talked about this in a lot of videos. When the x value exists, which we call it as the input value, and the only reason why we notate it as the x value, not a specific value, is because we know that the x value will be a variable. If you don't know what is a variable is a thing that changes or differs depends on times. So when the x value exists, our output of a function, which we notate as our y value, will be equal to 0. This is what the x-intercept will going to be when you convert it into some specific coordinates. Now the second thing that we need to talk about is what is the y-intercept. So the second thing will be what is the y-intercept. Well, the y-intercept is exactly the same kind of concept with our x-intercept, except the x value, which is the input, should always be equal to 0 because it is on the y-axis. And our y value, which we call it or notate as the output value, should always exist. And the only reason why we notate it as the y value because they are variables. So these are the main types of our intercepts in our quadratic functions. But if you go back to our original question, it says our ultimate question is solving for the zeros. Now, what is the zeros? What does it mean by zeros? Well, the only reason why I said that the intercept is the most important thing when it comes to solving this question is because it is about the intercept problems. Zeros means when y value is equal to 0, which means it is the same kind of concept with the roots. What is the roots? Roots is the x-intercept. What is the x-intercept? The x-intercept is when the x value exists and our y value is equal to 0. This is what the types of intercepts will going to be. Now we figure out that our zeros is the same thing with the x-intercept. So the most important thing in this case is how do we solve the x-intercepts? So we can see that ways to solve our zeros. And again, zeros is the x-intercept in our quadratic function system. Well, as we talked about it in a lot of last videos, there are basically 3 ways. The first ways of solving the zeros will be a substitution. So it is basically substitution plus a factorization. What it means by that is, let's say there is a quadratic function. For example, let's say there is y is equal to ax squared plus bx plus c. Let's say there is a quadratic function that is look like y is equal to ax squared plus bx plus c. And what I mean by this substitution, we substitute something to our function. Well, we know that our y value should always be equal to 0 in our x-intercept, so we substitute our y value as 0. And then we do factorization. What does it mean by the factorization? We're dividing our quadratic function y is equal to ax squared plus bx plus c into a binomial. For example, a times x minus z and the x minus p, for example. So this is a process, we call it as the factorization. And since we used our substitution and our factorization rule, we'll be able to solve for our zeros. And what is the zeros? Zeros will be the x values that makes this whole term equal to 0. What it will going to be? The first thing, z, and the second thing, p, as we have talked about it. So basically, it will be z, 0 and p, 0. This will be our x-intercepts that we try to solve. But in this case, our function is y is equal to 3x squared minus 6x minus 4. I don't think we can do factorization. So in this video, I'm going to talk about 2 ways how to approach this question. 2 ways, so there will be 2 videos separately. So as we can see, our x-intercepts We'll call it as the x-intercept in this case. Will be firstly z, secondly p. This we call it as the zeros in our quadratic function systems. But then we won't be able to, it won't be easy for us to factor this y is equal to negative 3x squared minus 6x minus 4. That means that people who made this question didn't ask us to if we know the factorization. Well, there are two other ways that we can approach this. The second way will be through our quadratic discriminant. It is a way that we call it quadratic discriminant. Well, the quadratic discriminant is one of the best ways that we can solve our zeros. It is the best way to solve the zeros without factorization. So the quadratic discriminant, and there are formula for doing it. The formula will be negative b plus or minus square root of b squared minus 4ac over 2a. So let's write it down in a more neat way. So our quadratic discriminant will be negative b plus or minus square root of b squared minus 4ac over 2a. And as we can see in my last videos already, a lot of videos from my YouTube channel, we used our quadratic discriminant a lot of times. Firstly, what is a? A is our leading coefficient. So a is our leading coefficient. A is our leading coefficient. What is b? Well, b will be our coefficient, but the difference between the leading coefficient and the coefficient is it is a coefficient of the x to the first power term. Lastly, what is c? C is a y-intercept. And using this information, our quadratic discriminant will exist. It is minus b plus or minus square root of b squared minus 4ac over 2a. Now think about the quadratic discriminant in a more specific way. Now people might think that what is this plus or minus? That shows that, so plus or minus I guess is the most important thing in the quadratic discriminant. Plus or minus shows that there shows two different roots, or so we'll call it roots, or we can also call it as zeros. And how do we do it? Well, we can divide this minus b plus or minus square root of b squared minus 4ac over 2a in two different ways. It is minus b plus square root of b squared minus 4ac over 2a. This is a first one where we add those things. The second thing will be minus b minus square root of b squared minus 4ac over 2a. So this one, all of them over 2a. This is a thing that added, so we all added into one thing. We added it into minus b, so we added it into minus b plus or minus b squared minus 4ac over 2a to make it clear, and also to make it simple. The plus or minus right over here includes both of them. Now, only thing you need to know in order to apply it is these three things. We already know it. We talked about it. A is leading coefficient, B is coefficient of x to the first power term, C is the y-intercept. Now let's actually apply and go back to our original question. Firstly, let's write our full function down again, the given quadratic function. The given quadratic function through the question. Well, the given quadratic function in this case will be y is equal to 3x squared minus 6x minus 4. This will be our given quadratic function. And from here, we need to somehow apply our quadratic discriminant in order to solve the addition of the roots. Well, as we can see, we are applying our a minus b plus or minus square root of b squared minus 4ac over 2a. This is exactly the same kind of concept with the first root. What is the b? Our b is negative 6, but we need to remember the negative sign. Negative plus negative 6. And then plus is not plus in this case, it is minus. Square root of inside it will be exactly the same thing. 36 minus 4 times 3 times negative 4 over, and for a denominator, our denominator will be 2 times a. What is a? 3. So, as a conclusion, everything will be exactly the same with the first thing except for the plus and the minus. So, if you think about it, it will be the first root will be 6 plus square root of 84 over 6. And the second root will be exactly the same except it is 6 minus square root of 84 over 6. This will be our two roots. What is our ultimate question? Our ultimate question is to solve the addition of it. So if you think about its addition, so let's write it down again. Positive 6 plus square root of 84. We have our over in order to express our denominator over 6 plus 6 minus square root of 84. So let's write 6 a little bit in an upper way. And we still have our divide sign to show its denominator. It should also going to be 6. Now we think about it in this way. Well, we're trying to solve for the addition, and the denominator is exactly the same. So we can add it together in the denominator. It will be 6 over and then upside. Well, we have 6 plus 6. And then we have our square root of 84 minus square root of 84. Well, plus 80 square root of 84 and minus square root of 84 will be cancelled out as 0. And we'll get 6 plus 6 divided by 6. 6 plus 6 is 12 divided by 6, which we're going to get us 2. 2 will be an addition. Addition between zeros. This will going to be our ultimate answer. Well, this was the first way to solve this question. Our first way was our quadratic discriminant. Well, this was exactly accurate and it was better than factorization, but it took us so long time. So this was our first way to support this question. In the next video, in the following next video, we're going to talk about the second way to approach this question. But this will be the procedure or the steps in order to approach this question will be exactly equivalent together because they are same questions.